I'm Jeremy Cordova. I'm the Environmental Project Manager for Public Works, and we're here on Watson Lake. We have one of our solar-powered water circulators behind us. These solar-powered circulators draw water from about 10 feet of depth, and they bring it up to the surface and they spread it out in order to aerate the water and to reduce the blooming algae. They move about 10,000 gallons per minute of water, and we have 4 of them installed in the lake right now. They are anchored to the bottom on those 3 floating buoys. Our next bit of action with the circulators is we're going to install a SCADA system on them so we can remotely monitor them. But for now, we perform regular visual monitoring to make sure they're functioning. And in addition to monitoring the circulators, we come out and we do water quality monitoring. And one of our primary tools is called the Aquatrol. So the Aquatrol is a water quality probe, and it has 4 sensors inside of it, and it measures a huge range of water quality metrics in real time, and they'll be displayed on my tablet. So what we'll do is we'll get the Aquatrol ready for action here. We put this cap on so that when it touches the bottom of the lake, the sensors don't get clogged with mud. We'll hook it up to our cord. Power it on, and it'll take a moment for the probe to wake up. The Aquatrol reports to the tablet through Bluetooth, and what we're going to see is once I get this in the water, we can see a huge range of water quality metrics, everything from temperature, pH, oxygen level, down to things like turbidity, salinity, dissolved solids, water depth, and we can see things like the resistivity and conductivity of the water, all kinds of really detailed water quality metrics that we can analyze back at the office to understand the water chemistry, the water quality, and the lake condition and health. So when you first put the probe in the water, you want to expose it to the lake water with a little splishy splashy, and that makes sure that there's no old fluid or anything left over in the sensors that could affect your readings. There's nothing in the probe but fresh lake water. And so usually what I do is I put the probe in the water and the sensors start to get exposed to the water. And it takes them a moment to kind of read, to sort of calibrate themselves to this new environment. The sensors have been sitting in a storage fluid while the probe is not in use. And so it's now adjusting to the water in the lake. And so one of the primary things I look at to make sure the probe is ready is the pH. You can see right now it's reading 8.1, which in my experience is very low for Watson Lake. So I do not think the probe is ready yet. I would expect the pH to be closer to 9, maybe 8.5. Not to say that we're going to enforce any pH reading, but we're just waiting for the probe to catch up to make sure that it does appear to be reading correctly. And we do calibrate the probe before and after use. That's mandated by the Arizona Department of Environmental Quality. And we maintain less than 7% error on every measurement. So it looks like we're about ready to go. We're settled at a surprisingly low pH of 8.2. But, you know, we don't make the data, we read the data. So that's the pH of the lake right now. What I'm going to do is I'm going to hit record, and we're going to start gathering data. And I believe this gathers 1 data point per second. And we're going to go all the way to the bottom of the lake, and then I'll bring it back up. And then after that, we'll take a couple of samples and do some measurements, and we'll go to another monitoring point on the north end of the lake. So what we'll do here, we'll start recording data, and we'll lower the probe. And what I typically do is I look at the depth as I lower the probe. So we're at about 2 meters, 3 meters, 4 meters, 5.5, 5 3/4. We appear to be settled at bottom or close to it. So usually when I think I've hit the bottom, I give a little extra cord just to make sure. So currently we're in 5.7 meters of water. And some of the things we're looking at, the pH at the bottom of the lake is the same as the top, which is a little unusual this time of year. The oxygen level at the bottom of the lake is about 63%, which is not surprising considering, in the summertime, the lake tends to split into a warm top and a cold bottom. And the cold bottom is more dense, so it settles down and it's unable to circulate with the warm top water. So you have completely different water chemistry and quality between the top and bottom of the lake. And that's the reason we sample and measure the top and bottom separately. So with this, we can stop gathering the data. And what I do with this data is I email it to myself and I process it back at the office. And then I can kind of chew on all the different water quality metrics, create some charts and things, make sure, our water quality metrics are acceptable. We don't have exceedances based on state standards. It's safe for public use. There we go. Gives you a sense of what's on the bottom. Okay, so we'll shut off the probe. The next thing we're going to check is called the Secchi depth. So this is called a Secchi disc. This disc gets lowered into the water with a tape measure, and you're simply visually monitoring to what depth can you see the disc. The depth to which you can see this disc is the depth to which light penetrates the lake. So that is the depth to which you will have growing algae, aquatic plants, and it's also informative regarding your water clarity and quality. Clearer water is cleaner water. So if we're able to get a deeper Secchi depth reading, we interpret that as positive, it's cleaner water. So here we go. It's a lot of current. So we're getting a very low Secchi depth reading right now. I think we'll try the back of the boat, given the water current going that way. Okay, so I'm losing the disc right there. And so what I do is I pull up to that point on the tape measure and we'll read what we call the Secchi depth, which is only 0.8 meters today. So it's very windy, the water's a bit turbid, there's a lot of current, and as a result, it's rather difficult to see the disc. It's not unusual. On a clear, calm day, we can see down up to about 10 feet or about 3 meters, but not today. So we'll make a note that the Secchi depth is low because of high winds and turbid water. And then what we'll do is we'll check our turbidity readings from the probe to see, if there's any excess or it's just a little wind, nothing to worry about. So we've gathered our water quality data and we've measured our Secchi disc depth. Our next step is to gather a top water sample. So we're at the south end of Watson Lake and we're going to get a top water and a bottom water sample. To get our top water sample, we just grab it. You want to get your top water sample from about 6 inches below the surface so you can avoid any top scum that would affect your measurements. And you want to fill the bottle 100% so that the water doesn't off-gas into the air in the bottle and affect the chemistry of the water. Under normal circumstances, these samples would need to be kept in a cooler on ice, but I'm traveling to our water analysis lab right after this, so they can remain at room temperature. Our next step is a bottom sample, which is a little bit more technically challenging. We have to use this tool that's called a beta bottle. So what we do is we open the beta bottle and we pin the two ends like so. And we're going to lower it down to the bottom of the lake. And then when we do that, we're going to drop this weight and it's going to close the bottle and gather the sample. So we know from the AquaTrol that there's about almost 4 meters of water here. So that gives you an idea of how deep we need to go. We'll start by, at minimum, triple flushing the bottle to remove, maybe there's a little dirt or a little dried out water from the last sampling. We'll just make sure the bottle's clean and filled only with Watson Lake water. We're lowering and we're feeling for when the rope goes slack. And then we know we're on the bottom of the lake, at which point we pull back a few inches. And there we go. So let's come over here with our bottle. Back side of the boat. And just like before, we're going to do a complete fill of the bottle. And we oversize our sample so we don't have to worry about spilling water or anything like that. This has a drain valve on it, but it's currently a little bit clogged, and it's better to just get your sample this way. Total fill. Cap it off with no air. And that's your bottom water sample. So we're here on the north end of Watson Lake at our monitoring station. We're about halfway between the northernmost circulator and the dam in the deepest pocket of the lake. We're expecting around 12, maybe 10.5 meters of water in this area. And the first thing we're going to do is set up our sample bottle, and we're going to grab some bottom water. So here we go. Triple rinse and let it drop. There we go. I'm at the bottom. Come up about 6-10 inches. Double check that you're correct about being at the bottom and let your weight go. And you can feel the weight on the cord, and that's why I'm standing here waiting. I can feel the weight dropping, and it just hit the bottom. And we do this at every lake, every month, top and bottom. All right, first time's the charm. Look at that water. It's dirty, it's mucky, it's cloudy. That's very typical of the bottom of your lake. Woo! I like to describe it as fragrant, although that's not many other people's terminology for the bottom water. So you can see there's a dramatic difference between the top and bottom waters in the lake. And this time of year, the top water is warm and less dense. It sits above the bottom water, and they do not mix. And that's the reason why we're here checking both top and bottom water completely separately, because they are so distinct. So we visited our 2 monitoring points, and we've gathered our 4 water quality samples as well as our data and other measurements. And with that, our monthly monitoring of Watson Lake on the lake is concluded. We thank you for watching and for your support of the City of Prescott and our Healthy Lakes program.